There are 6 types of forces, and we're going to figure out what they all are as we go through this paper. So make sure you have this in front of you and make sure you write down the notes because you're going to use these on the types of forces lab. The first type of force is called buoyant force, the first type we're going to look at. Buoyant force is a contact force because it deals with the force exerted upward by a liquid on a submerged body, such as a message in a bottle floating in the ocean, or a ship or boat floating in the ocean or sea, or a piece of wood floating in water. The symbol is right here, capital F with a subscript B. And then here's an example of buoyant force. With this boat floating in the water, the buoyant force is pointing up, and the force of gravity is pulling that boat down. If the buoyant force is greater than the force of gravity, then the boat floats. If gravity, the force of gravity, is greater than the buoyant force, the boat sinks. Next force is magnetic force. This is the attractive and repelling forces between a magnet and iron, or between two magnets, or between a magnet and another object. For example, Earth's magnetic field, or a magnet holding a piece of paper on a refrigerator or whiteboard. Symbol is capital F, subscript lowercase m, and I have a couple examples here of two magnets. The first one is a north magnet and a south magnet being attracted to each other because opposites attract. So the force from the north magnet on the south magnet is F sub m sub 1, and the other one is F sub m sub 2 for the south magnet on the north. And then if we have two south ends of a magnet, those are going to repel, so the arrows are pointing in the opposite directions. But one of those would be F subscript m subscript 1, and the other one F sub m sub 2. If we're dealing with a magnet and some other object, like another metal object, such as maybe a paperclip, for example, then the force on this would be causing the paperclip to go towards this, which means it's being attracted like that. So this would only be F sub m sub 1, or the force of the magnet. We really don't even need the 1 there because there's only one force. The paperclip does not have a magnetic force at all. The next force we're looking at is electrical force. The symbol, capital F, subscript Q, and for this, very similar to magnetic force, except the electrical force deals with the force that causes like charges to attract each other and unlike charges to repel each other. These are positive and negative charges from particles, small particles. So anyway, a positively charged particle, such as the positive end of a battery and the negative end of a battery, the positive charged particle would be F sub Q sub 1, and the arrows pointing toward each other show that they are being attracted. Positive is being attracted to the negative, F sub Q sub 2. And then positive, positive, same charges, they repel each other, so those arrows would be going in opposite directions. Examples of this are socks sticking to a fleece blanket after running laundry in a dryer, or a balloon sticking to your clothes after you rub it on your clothes. Next force is gravitational force, the force of attraction exerted between different particles of matter. And as you look in here, this gravitational force is a non-contact force. Electrical force is a non-contact force. These two items are not touching each other. Magnets, they are not touching each other. You can feel the force between them without them touching each other. Whereas the buoyant force is a contact force. The water and the boat are touching each other. So back to gravitational force, symbol, capital F, subscript G. And gravitational force, we're looking at forces between one large object and another large object. The trick here is that the larger the mass of the object, the more of a force of gravity it has. The lower the mass, the less of a force of gravity. So the Earth and the Moon, they both are large objects with a lot of gravity, and the Moon orbits the Earth because the Earth has more gravity, a larger mass, than the Moon. And the Moon affects the tides on the Earth. It causes high tide and low tide along with other things because it does have a considerable amount of gravity, but nowhere near as much as the Earth has. The Moon's gravity is 1/6 that of Earth. Here's how we write it. In this case, we're talking about a falling box falling toward the Earth. The force of gravity always points toward the Earth, and this is how we label it. There is another force that plays into a factor here, maybe air resistance as this falls, because falling objects can only fall to a terminal velocity because of air resistance. So in that case, air resistance would be pointing in the opposite direction of the fall. The next force, force number 5, is the elastic force, the force exerted on a material when it is stretched. This is a contact force because two objects are touching. We're looking at stretching a rubber band or bungee jumping. This is the symbol F with a subscript of an X, not f of x like in math, not a function, a subscript here. Anyway, this is a wall and a hook, and this is a rubber band attached to the hook. And as the rubber band is being pulled away from the wall and the hook, this is the tension force, and the elastic force wants to make that rubber band go back to its normal size. The final one is frictional force. Here's our symbol, the capital F with a lowercase subscript f. So frictional force, also known as the force of friction or just plain friction, the force that resists the motion of objects as they are rubbing against each other. Another contact force because two objects are touching and rubbing against each other. This skier going down this hill, their force of motion, the motion is going down the hill, and the force of friction is pointing in the opposite direction of motion. So it is pointing up the hill, and we label it as so.